Okay, so the second part of lesson 4.5, this one is asking me to sketch the graph of this function. So well, what I'm going to do is like walk through all the different steps to find all those different pieces that will help me graph it a little bit quicker than normal. Okay, so the first thing that was on my list was to find x-intercepts. And that's where it's either, you can think of it two ways, either the zeros of the numerator or y equals 0. So let's talk about that. So x-intercepts are where your y value equals 0. So if I have this function, y equals -3 over x plus 3, really that is, I'm going to think of it as 0 equals -3 over x plus 3, which basically means I'm going to multiply both sides by x plus 3, which gives me 0 over here still equals -3. Well, that's not possible. So there are no x-intercepts. Okay, so there's my first part. I keep going out of focus there. Okay, the second thing that's on my list of things to do is to find my vertical asymptotes, which is the zeros of the denominator. So in this case, the zeros of my denominator, if I set this equal to 0, x equals -3 is a 0 there. So I would have a vertical asymptote. So let's go ahead and start graphing this so that we have it. I'm just going to start it like this because I'm not sure exactly what's going to happen on this graph. Okay, so I'm going to start it like that, and I know that at x equals -3, I have a vertical asymptote. So 1, 2, 3. So I have an asymptote going like that. And I always do asymptotes with dashed lines, so make sure that you do that. Okay, so then the third thing on my list of things to do is finding the y-intercepts, which is where your x value is 0. So if I go up to my function, anytime x is 0, that's going to give me a y-intercept. So if I plug a 0 in right here, I get -3 over 3, which is -1. So that means at -1 on my y-axis, I have a y-intercept. I had no x-intercepts, so I didn't put any on this axis. Okay, the fourth thing on my list is that horizontal asymptote situation. So horizontal asymptotes, that's where I look at my degrees of my numerator and my denominator, and then I check these three situations. Okay, so if I do my degree of my numerator, in this case it's 0. The degree of my denominator in this case is 1. So that means my n value is less than my k value. And according to this, if n is less than k, then I'm going to have a horizontal asymptote on the x-axis, or y equals 0. So this is my horizontal asymptote right through there. So I'm just going to remind myself that that's there because you can't see it very well, but we'll keep that in mind. Okay, so the last thing I would do, so I know that I'm going to have something happening either down here or up here where it's going to like stop here and stop there because there's asymptotes. Same thing with this side. I'm going to have something happening either up here or down here. To me, it looks like it's pretty obvious. It's going to be down here because I've got an intercept right there. So that makes me think I'm probably going to have something going kind of like this. So I'm just going to like sketch out that theory that I have. But I'm going to check some values and just see what happens. So I have a more definite idea of what's happening. So I'm going to check, I think I'll check -5 and -4 over here so I can see this idea. And then I'm going to check maybe -2 and -1. I don't need to check -3 because I know that's an asymptote. And then maybe check 1. I don't really need to, but it gives me a better idea of what's happening. All right, so if I plug in -5 right here, I end up with a -3 over -2, which is 3/2, or I could say 1.5. So 1.5, so maybe about right there. And then at -4, if I plug that in here, I get -3 over -1, which is 3. So at -4, 3, I have a point. Okay, so that makes me feel pretty good that this is what's happening. I know I've got an asymptote going this direction. So my end behavior is that it's going towards negative infinity there. As it's going towards negative infinity, it's going closer and closer to 0. And then this is definitely going up that direction, never going to touch this asymptote right here. Okay, then this other side, if I plug in a -2 right here, I get -3 overall. So at -2, -3, I have a point, and look at that. I already feel pretty good about this, so I'm actually not going to go ahead and sketch those other ones. This point right here just kind of confirmed my idea. I know that it's going down this direction towards negative infinity, and then I know as x is going towards positive infinity, this is getting closer and closer to 0. Okay, so there's a sketch of that one. Part B is it's asking me to do the same thing. So I would go through all of those same things, but I would also make a point to remind myself that if these are the same, that tells me I'm going to have a hole at x equals -1. So maybe find that point so that you can put it on the graph. So if I put -1 in here, that would be, let's see, 5 times -1 is -5 plus 3 is 2, -2. And then on the bottom, if I plug -1 in here, that gives me -3 minus 7, which is -10. So let me just simplify this. It comes out as -2 over -10, which is the same thing as 1/5. So at the point -1, 1/5, I have a hole in the graph. So let me show you what that would look like. Okay, so at -1 and then 1/5 of the way up, so just barely, I don't know why I put a dot there. This is a hole in the graph, which tells me I have like an open dot right there at that point, which is really off, but you get the idea that there's this open spot right there, and then I'll see what's happening around it. Okay, if I check my x-intercepts on this one, that's that first thing that I did. I plug 0 in for y and solve from there, so I should end up with 0. When I multiply by this, I get 5x plus 3 times, I don't know why I made it 2, x plus 1. So that tells me I'm going to have, let's see. Oh, I'm sorry. Let me go back for a second. I don't have to put that x plus 1. And why do I not have to? Because those cancel. So that's going to save me a little bit of trouble. So then when I just solve this, that gives me -3 equals 5x. So -3/5 equals my x-intercept. So at -3/5 of the way over, that's my intercept right here. Really close to that spot that's open. And then second, I'm going to look at my vertical asymptotes. Vertical asymptotes happen where your denominator is 0. So in this case, that's going to be at when 3x minus 7 equals 0. So if I solve that out, I get 7/3. And that's my vertical asymptote. So remember, 7/3 is the same thing as 2 1/3. So at 2 1/3 of the way over, I've got this vertical asymptote going through there. It's kind of at a weird spot. And then the third thing is my y-intercepts. My y-intercepts in this case are where x equals 0. So if this was 0, let's start up here. If this was 0, I would get 3 on top. If this was 0, I would get -7. So at -3/7. So -3/7 would be about, I don't know, let's say it's about right there. Pretty close to halfway down. Okay, and then the fourth thing, horizontal asymptotes. So let's check our degrees again. So if I were to multiply this out, and well, really, I can still think of this as being gone. So if I just think about the degree of this one, I get 1. And if I think of the degree of the bottom, I also have a 1 there. So that means that n and k are equivalent to one another. And if you look back at your sheet, again, your little cheat sheet, if n and k are the same, then we use the ratio of those leading coefficients again. So those leading coefficients in this case are a 5 and a 3. So that means at 5/3, I have a horizontal asymptote, which is the same thing as 1 and 2/3. So at 1 and 2/3 of the way, I have a horizontal asymptote. Okay. Then I'm going to do the same thing I did on that last one where I just kind of check a few test points here just to kind of solidify what I'm thinking. So the first thing I want to check is, oh, I messed up. This was at 2 1/3, not -2 1/3. So let me go back. Sorry about that. How many of you caught me, I wonder? How many of you were already typing an email to me to say, Miss Evans, you're wrong. Okay, so 2 1/3. Sorry about that. Okay, so this tells me that something's happening over here. This hole right here doesn't mean that the function is just going to stop there. It just means there's nothing here, but there could be things on either side. So I'm thinking since there's points down here, I'm thinking this is probably going to go like this direction, and then this is going to go back up this direction, but I'm going to choose a test point to check my theory here. So let's choose maybe -2 to see what's happening. If I plug -2 in here, I get -10 plus 3 is -7. If I put -2 in here, that gives me -6 minus 7. It's -13. So I end up with positive 7/13. So at -2, I am at 7/13 of the way. So that's, let's say it's about right here. So that looks pretty accurate then. I think my idea of it going up towards that asymptote is good. So I feel good about this piece here. Maybe let's check over here. So maybe I want to check 3 or 4. Let's check 3 and see what's happening. At 3, if I plug that in, I've got 15 plus 3 is 18. This would be 9 minus 7 is 2. So I get 18 divided by 2, which is 9. So at 3, I'm way up here at 9. So this was 2, 4, 6, 8, 9, about right there. Let's plug in 4 just for kicks so that I know kind of what's going on. So if I plug in a 4 here, I get 23. Plug in a 4 here, I get 12 minus 7, which is 5. So I'm getting about 4 3/5. Okay, so at 4, I'm at 4 3/5 of the way up. So about right there. So this looks to me like I've got a pretty steep piece happening here, but it still has to follow this asymptote right here for its end behavior. So it has to go kind of that direction and flatten out. So that's what my graph would look like. Okay, last one I want to talk about is this idea of an oblique asymptote. And I already know that oblique asymptotes do show up. Vertical and horizontal and oblique show up on the final exam. So I would definitely pay close attention to this one. So I know that, so let's just talk about our vertical and our horizontal asymptotes. So our vertical asymptote in this case is this equal to 0. So 2x minus 4 equals 0 means 2x equals 4, so x equals 2. So this is my vertical asymptote. Okay. The horizontal asymptote, so this is where we take our degrees, right? So the degree of the top is 2. The degree of the bottom is 1. So that means n is greater than k. And this is that weird case at the bottom. So when n is greater than 1, then there's no horizontal asymptote, but there could be an oblique asymptote, and that's where we have to use long division. Okay, so there's no horizontal asymptote, which I'm just going to call HA. But the oblique asymptote, so here's what I want you to do. I want to take this function x squared. It's x squared minus 9. Well, that tells me that my x term is missing, so I'm going to say plus 0x minus 9, and I'm going to divide that by my 2x minus 4 and see what happens. So if I do that, first let's think about 2x times what gives me x squared. So this is where a lot of people have a hard time. 2x times something gives me x squared. So first of all, I have to take 2 times something to get 1. Well, half of 2 is 1, so that works. And then x times something to get x squared would be x. So this would be 1/2 x, and I'm lining that up with the x term. And then I'm going to multiply this out. So 1/2 x times 2x squared, or times 2x, is x squared. And then negative 4 times 1/2 x would be negative 2x. And then I'm going to subtract, which means I have to make that plus now. So this is nothing. This is 2x minus 9. 2x will go into 2x one time, one positive time. Multiply again. 2x times 1 is 2x. 1 times negative 4 is negative 4. Subtract it away. So that gives me a negative 5 left over. So I really don't care about this remainder, but this piece right here is your oblique asymptote. So let me show you what that would look like. So if I'm graphing this, and I'm not going to graph the whole thing, I'm just going to show you where these asymptotes are real quick. So a vertical asymptote at x equals 2. So at 1, 2, here's my vertical asymptote. So I'm going to get some more points on here. These are pretty messy. I apologize for that. Okay. This is my, so y equals, this is my oblique asymptote. So if I graph this line, so start at 1, my slope is 1/2, so down 1 over 2, down 1 over, why am I going down 1? Up 1 over 2, you guys are really going to have to stay on me here. Up 1 over 2, there we go, or down 1 over 2 this direction. This is my oblique asymptote, which means something weird is happening there. So a lot of times you'll find that, and I'm not going to test anything on this one, but sometimes you have graphs that look like this. Sometimes you'll have something that looks like this. It just depends on what situation you're in, right? So these are all of my options. So then I would have to take test points and actually check and see what's happening.